Today we're going to talk about some geometric terminology that you'll need to know moving forward. Some of the items that we talk about today you've heard of before, but we're going to formalize some definitions and talk about some naming conventions that you need to know to complete this unit. And we're going to start with the term point. You know by now that a point is an exact location in space. Sometimes you've heard it referred to as being similar to a pixel on a computer screen, and that's absolutely right. But we're going to talk now about how to name a point. A point is always named by a single capital letter. So if I call this point on the screen, and sorry that point is kind of big, if I call that point A, I could write the name of that point by simply using that capital letter A, or I could write the phrase point A. They both mean exactly the same thing and refer back to that same point. When we talk about a plane, we're talking about an infinite flat surface. It's kind of hard to picture and it's kind of hard to describe, but it's kind of like if you could take a wall or a ceiling or a floor and have it extend on forever in all directions. That would be a plane. We define a plane by using at least 3 points on that plane, and the 3 points need to be non-collinear, meaning that they can't all three make a straight line. So I have these 3 points, points R, U, and N, that are inside my plane. Notice that they definitely don't make a straight line. And so those are my non-collinear points that I'm going to use to define my plane. I can use more than 3 points if I'd like. And when I name that plane, I can use any combination of those 3 or more points. Order absolutely doesn't matter because they're all within the same plane. The symbol for plane kind of looks like a rhombus, or you could extend it out just a little bit and have a quadrilateral. But I could use the symbol for plane, meaning plane RUN, plane NUR, and so on. Or I could use the word plane instead of the symbol. A line is a straight path in a plane that goes on forever in opposite directions. The fact that it goes on forever in both directions is why your teachers are forever getting after you to remember to put arrows on both sides of your line. That distinguishes a line from some of the other objects that we're going to talk about today, so they're kind of important to have. When we name a line is always named by 2 points on that line. And since we're just talking about 2 random points on the line, the order is not really going to matter. So if I create points A and B that are on the line on my screen, I can call it line AB or I can call it line BA. And if I want to write that in symbolic notation, notice I use the little symbol for line, which is the double-sided arrow, and I put it over the combination of the 2 points on the line. If I had a third point on a line, say I had a point C that's in between point A and B, I could call it line ACB as long as I have the points in order. I could call it BCA or whatever, but it only requires 2 points to define a line. Lines can also sometimes be named by lowercase cursive letters. When you see a graph, sometimes you'll see the lines called L or M or N, but they're always lowercase cursive letters when you're not using the 2 points on the line. A line segment is simply a portion of a line. It has a starting point and it has an ending point, and we call those 2 points endpoints. And of course, a line segment includes all the infinite number of points directly in between the 2 endpoints. If I call those endpoints A and B, I can call this segment AB or I can call it segment BA. It simply needs to know where it starts and where it ends. If I want to write the name in symbol notation, I'm going to use the symbol for a segment, which is a line with no arrows, of course, since this doesn't extend beyond the two endpoints, and put it over the top of AB or BA. Again, if I had a third point in between A and B, I could include that letter in between A and B in the name, and I could have like ACB or whatever, but it only requires the two endpoints to actually name a line segment. Now, a line segment, unique to the other objects we've talked about so far, have a name, but they also have a measure or length. For instance, if I used a ruler to measure this line segment, I can see that it's approximately 2 inches long. In order to say that this segment is 2 inches long, though, you need to use the correct notation. A segment's name and its measure is every bit as different as your own name and your height. You wouldn't say that somebody named John being 6 feet tall, you wouldn't say John equals 6. That doesn't really make sense. So you need to say John's height is 6 or John is 6 feet tall, right? Well, the same thing goes with a name and measure for a segment. Notice that when I'm talking about the name, I use the symbol over the top. When I talk about the measure of the segment, I don't put the symbol over the top. So when I want to say the segment is 2 inches long, without the symbol, this reads, the measure of AB is 2 inches. You do need to know the difference between the name and the measure notation for segments. Next we have array. Array is also part of a line, but it only extends forever in one direction, and it has a beginning point that we call an end point. Now, if I simply talked about that end point of array, it could be an array that goes off in really any direction from that point, right? So to be really specific about this array in particular, I have to have more than one point in the name. Array is always named starting with the endpoint and then another point on the array that the array passes through. So if I call this array AB, the order is very significant. It tells me that the array starts at endpoint A and then goes through point B. If I want to write that symbolically, I use the symbol for array, which is always the right pointing arrow. Don't ever name an array with an arrow pointing left. That doesn't mean the same thing. So I can say array AB, meaning that it starts at A and goes through B, but I couldn't say array BA because that would mean it started at B and then went through A and extended on in that direction. And that's not what we have. So make sure you always start with the endpoint and then one other point that the array actually passes through to specify direction. Parallel lines, I know that you already know what parallel lines are. Lines in the same plane that never intersect, and we've talked before about how they have the same slope. But let's take a look at notation. Two absolutely vertical little line segments together represent parallel. So this notation tells me that line AB is parallel to line CD. Watch out for the two parallel line segments. When I want to write the notation for perpendicular lines, of course, perpendicular lines are two lines that intersect to form 4 right angles, and don't ever assume in a picture that they are right angles unless you see the little square that tells you it's a right angle. The symbol for perpendicular looks like an upside down capital T. In this picture, this symbol or symbol notation is telling me that line AC is perpendicular to line BD. Next, let's quickly talk about angles. One definition of an angle is a figure formed by two rays that have a common endpoint. And that common endpoint we call the vertex. Now, an angle doesn't have to be just two rays. It can be two straight objects of any type. I can have an angle where two segments intersect, or where a line intersects a segment, or any other type of straight objects coming together to form an angle. When we name an angle, we name an angle by 3 points that are actually on the angle itself. And one of those 3 points needs to be the vertex. Order is absolutely going to matter in an angle name, so let's go ahead and put 3 points on this angle. The two rays in this picture are called the sides of the angle, and I've put 1 point on each side. If you look carefully, this angle is kind of formed when you move from point A to point B and then to point C. Or I could go in the opposite direction and go from C to B to A. Both patterns follow along the angle itself. If I went from point B to point A and then down to point C, that doesn't really follow my angle, so I can't use that order of points in the name of the angle itself. So notice for the angle name, I actually use the symbol for an angle, and we put it in front this time instead of on top. I can call this angle ABC, or I can call it angle CBA, because those again are the patterns that follow along the angle. The important part here in an angle name, in any angle name, is that the vertex is always the middle letter. And sometimes when this angle is alone off in space, you'll see it only named for the vertex. Sometimes you'll see this called angle B. But that's rare because often you'll have other angles on the page that you have to consider. Angles, because angles can be measured in degrees, also have names and measures. We already talked about how to name an angle, but when we want to talk about the measure, whether it's in degrees or radians, I need the little lowercase m in front of the angle symbol. This would be read the measure of angle ABC. So if this angle, let's say, had a measure of 75 degrees, I need to make sure the m is there, and I say the measure of angle ABC is 75 degrees. Just a quick reminder of the 4 different types of angles. We have acute angles that are greater than 0 but less than 90 degrees. We have obtuse angles that are greater than 90 but less than 180 degrees. We have right angles that are, of course, exactly 90 degrees. And something called a straight angle when it stretches out and measures exactly 180 degrees. Now let's talk about circles, and we are really close to being done. Hang in there. Circles are defined as a closed figure that lies in a plane, made up of all points in the figure that are the same distance from a center point. In other words, circles are defined by a center point and made up of all the points that are equidistant from that point. Hence, circles are named for that center point. If I call this center point point G, then this circle is actually named circle G. And lastly, we have an arc. An arc is simply a portion of a circle that's been separated from the rest of the circle. This arc is actually called a circular arc for that reason. An arc has a length just like a segment does, but it's not straight. Arcs can be measured in radians, it can be measured in degrees, or it can be measured in good old units like inches or centimeters or yards. An arc is actually named for the two end points on the arc. So if I put the points in where the arc begins and where the arc ends, I can name it arc AB, or I could name it arc BA as long as I have the two endpoints included. Or I could use the symbol for arc if I wanted to write it in symbol notation. There are times when you'll have a third point somewhere on that arc. If I put a point in here and call it, let's say, point C, it is possible to have more than two letters in the arc name. I could call this arc ACB as long as the two endpoints are on the outside of the name, and that would just mean arc AB that goes through point C. You don't see that a lot, but it will happen occasionally. And last but not least, the difference between an arc name and a measure. Just like our angles, we're going to put that little lowercase m in front of the name of the arc to indicate measure. So I could say the measure of arc AB is, say, 60 degrees. All right, I think that's enough for today. I hope the rest of your day goes fantastically well, and I'll see you next time.